Before we had this one incredible machine, everything depended on muscle.
Yep, your muscle, a horse's muscle. That was it.
So if you needed to do any kind of heavy work, like, say, drain a giant flooded hole in the ground, you were pretty limited.
Very limited. But then this one invention comes along.
And suddenly you have the power of 1,000 horses on demand, all from one machine. It changed, well, everything.
It's kind of amazing when you think about it. The entire foundation of our modern world, all our mechanical engineering, it really all comes from harnessing the simple force of boiling water.
You just capture the pressure, and you get work.
That's the core idea, the steam engine. It was basically the starting gun for the industrial age.
So we're going to break down how it works, why it was such a massive deal in the 1800s, and maybe most importantly, how this really old tech still affects your life every single day.
And the initial push for it wasn't about trains or boats. It came from a place of, well, industrial desperation.
In coal mines, right?
Exactly. The deeper you dug for coal, the more the mines would fill up with groundwater.
So you're constantly fighting a flood.
Constantly. They needed a cheap, powerful, nonstop way to pump thousands and thousands of gallons of water out, just so the miners could get down there and work.
And that brings us to Thomas Newcomen, early 1700s.
Right. His engine was one of the first practical designs that could actually do the job. But it was enormous, the size of a small house.
And it had a huge problem.
A huge problem. It was incredibly thirsty. It needed an absurd amount of coal to keep the water boiling. So it worked, but it was just financially painful to operate.
Okay, so that's where James Watt comes in, the big name everyone knows.
He's the one who really cracked the code. See, Newcomen's engine worked by shooting steam into a cylinder and then shooting cold water into that same cylinder to create a vacuum.
Which sounds, horribly wasteful.
It was. Every single time you spray cold water in there, the whole cylinder cools down. Then you have to waste a ton of fuel just reheating it for the very next stroke.
So that inefficiency, that was the main engineering problem to solve. How did Watt actually fix it?
He came up with the idea of the separate condenser. This was the genius move.
A separate condenser.
Yeah. So instead of cooling the main cylinder, he let the used steam escape into a totally separate cold container, the condenser.
Ah, so the main cylinder stays hot all the time?
Stays hot all the time. And by doing that, by only cooling the steam in that separate chamber, Watt cut the fuel needed by about 75%.
75%?
That was the revolution. Suddenly, factories didn't need to be built next to a river for a water wheel. You could build a factory anywhere you wanted, and steam power just exploded across England and the United States.
Okay, so let's get into the mechanics. The basic idea is simple, right? Turn heat into motion.
That's it. Heat energy becomes physical work. We can break it down into a few main steps.
Okay, step one has to be the heat, the boiler.
Right. You have a furnace, a massive fire, heating water in a big sealed tank, the boiler. You get it to 212 degrees Fahrenheit, it boils, and you get a ton of high-pressure steam that really wants to expand.
Step two, put that pressure to work, the power stroke.
That steam gets piped into a cylinder that has a sliding piece inside called a piston. The steam pushes that piston forward with, thousands of pounds of force. That's your mechanical energy right there.
Got it. Then step three must be getting rid of the old steam, the exhaust.
Exactly. A valve opens, the used low-pressure steam escapes, either into the air or, in Watt's design, into that condenser.
And that release of pressure lets the piston slide back to the start.
Right. And that's the cycle. Step 4, a new blast of steam comes in, and the whole thing starts all over again, over and over.
But wait, that back and forth motion, that shaking? How does that turn a wheel? That seems like a pretty big leap.
It was a huge leap. That's where you get clever mechanical parts, like rods and cranks. The rod on the piston is connected to a crank, kind of like the pedals on your bike.
Okay, I can picture that.
It converts that push-pull motion into a smooth circular motion, and that turns a huge, heavy flywheel.
And the flywheel is important because
it stores energy. It's so heavy that it keeps everything turning smoothly between those powerful piston blasts. It evens everything out and gives you a steady supply of power.
And that whole system needs a ton of heat, which means you need a serious fuel source.
And for the Industrial Revolution, that fuel was coal.
Why coal? Why not just use wood?
Because coal, which is a black rock you have to dig up, just burns hotter and much, much longer than wood. It gives you that sustained, intense heat you need to keep a massive boiler under pressure.
The scale of this must have been incredible.
It was. The coal mining industry became essential. And to run the engines, you had workers called firemen or stokers.
And their entire job was just shoveling coal.
All day, all night. A steam locomotive on a long trip might need several tons of coal. It was just back-breaking, constant work.
But all that coal burning had to have a downside, a big one.
Oh, a massive one. It produced just incredible amounts of smoke and soot and ash. In any industrial town, the air was filthy.
So that classic image of Victorian London with all the dark, soot-covered buildings, that's from this.
That's directly from this. The soot literally coated everything. People talked about the air being thick and black. It had serious health effects, and it was pumping chemicals into the air that we now know cause things like acid rain.
But they kept using it.
They did, because it was, by far, the cheapest and most powerful fuel source they had. The need for power was just so great that it overshadowed any of the environmental concerns at the time.
And that power didn't just stay in the factories. This is where it gets really visible. They put the engine on wheels.
And you get the steam locomotive, the train, the famous early one, the rocket, proved it could be done.
This was the one that showed steam travel was fast and, relatively safe.
Exactly. And to understand the impact, you have to think about what came before. A trip of a few hundred miles could take days, maybe a week, in a horse-drawn wagon on a muddy road.
And
Suddenly, trains are hitting speeds of over 30 miles per hour. For someone in the 1800s, that felt like teleportation. It just shrank the world.
So the whole map of the country gets redrawn.
Instantly. Railroad tracks start connecting all the major cities. Farmers could suddenly ship milk or vegetables to a city hundreds of miles away before they went bad.
And that steam whistle.
That sound became the symbol of progress, the sound of a connected world.
And it didn't just stop on land. It completely changed ocean travel, too.
Think about it. Sailing ships are amazing, but they're totally at the mercy of the wind.
Right. No wind, you're just stuck for weeks.
Steamships didn't care about the wind. They used giant paddle wheels or propellers to just push through the water at a steady, predictable speed. That reliability was everything.
It meant you could actually have a schedule. From London to New York.
A regular, fixed schedule. It sped up global trade, moved mail, and carried thousands of immigrants to new homes. And the ships got stronger, too. They moved from wood to iron and then to steel.
So beyond travel, the engine is also what creates the modern factory.
Absolutely. One central steam engine could power dozens of different machines all at once, all through a system of belts and pulleys.
And that's the birth of mass production.
That's it. You could have rows of spinning machines and looms all running at the same time, making identical shirts or shoes or tools way faster and cheaper than ever before.
Which caused this huge social change. People left the countryside to go work in the cities.
A massive shift. You left the quiet farm for a crowded, incredibly noisy city. The work was loud, the hours were long. It just completely changed family life.
And what's interesting is how steam power boosted the very industry that created it mining.
It's a perfect loop. You need steam pumps to get the water out of the mine so you can dig up the coal.
And the iron ore.
And the iron ore, right. And then you need steam-powered cranes to lift all that coal and iron out of the ground. That raw material then gets used to build more engines, more tracks, more factories.
And it even changed farming.
It did. They made portable steam engines you could haul out into a field.
And what would you do with it?
You'd hook it up to a machine that threshed grain or baled hay. One machine could do the work of a whole team of people and horses in a fraction of the time.
Which, again, meant you needed fewer workers on the farm, which pushed more people toward the cities.
It's all connected.
But running these things, it sounds incredibly dangerous. You've got a high-pressure tank of boiling water right next to a giant fire.
It was extremely dangerous. If the fire got too hot or the water level got too low, the pressure inside that boiler could shoot up.
And then, boom.
A boiler explosion was catastrophic. It was like a bomb going off. The early days of steam were filled with really tragic accidents.
So engineers had to figure out how to make them safer.
They did. They developed the pressure gauge dial that shows you the exact pressure inside, so you have a warning.
And more importantly,
the safety valve. A simple but brilliant device. It was designed to automatically pop open and vent steam if the pressure got too high.
so it's like a built-in emergency release.
Exactly.
Yeah.
And after a number of early disasters, governments stepped in and passed laws. They required regular inspections of all boilers to make sure they were safe to operate.
So, this age of steam, it dominated for more than a century. Why did it end? Why don't we see steam trains everywhere now?
Well, basically, better engines were invented. The internal combustion engine, the kind that runs on gasoline or diesel, was just way smaller and more convenient.
You don't have to wait for the water to boil.
You just start it up and go. And then you have electric motors, which were cleaner, quieter, and much easier to maintain in a factory. Steam engines were just too big, too heavy, and too expensive to keep feeding with coal and water.
So by the mid-1900s, it was mostly over.
For things like trains and ships, yes. Most railroads switched to diesel or electric.
But the principle of steam power isn't gone, is it?
Not at all. In fact, it's how we get most of the world's electricity today.
How does that work?
Modern power plants are still, at their heart, steam engines. They just use a cleaner heat source, like a nuclear reaction or natural gas to boil water.
Yeah, that's steam.
That high-pressure steam doesn't push a piston anymore. Instead, it blasts against the blades of a giant machine called a turbine, spinning it incredibly fast.
And that spinning turbine is what generates the electricity.
That's what turns the generator. So the power lighting this room, charging your phone, it almost certainly started as steam. The same basic idea that powered the rocket is still powering our digital world.
And I assume they're way more efficient now.
Oh, incredibly efficient. They cool the used steam back into water and pump it right back to the boiler to be used again. It's a closed loop. Almost nothing is wasted.
So when you pull it all together, the steam engine really did just change everything. How we travel, where we live, what we make. It was the essential leap that created modern society.
It truly was an incredible era of progress, but one that came with some really serious consequences, like all that pollution and the safety risks.
So think about that trade-off. All the pollution and the danger that came with the age of steam, all in the name of power and progress. If you had the choice today, what major modern technology would you decide to replace if you knew a cleaner, faster, and safer version was ready to go? Something to think about. Good luck with your studies.